Okay, so in this lesson, 3.7, we're doing determinants and this thing called Cramer's rule. Who's this Cramer guy? Why is he so big on rules? So our three objectives, first one, we're going to find a determinant of a 2x2 and a 3x3 matrix. Maybe you can get from that this is only dealing with square matrices. That's true. And number two, we're going to find the area of a triangle in the coordinate plane using determinants. It's one of the applications of determinants. And if you look over there on the right side where it says assignment extra credit, the extra credit for this 6 weeks for 5 points has to do with objective 2. And then finally, objective 3 here, we're going to apply this Cramer's rule to help us solve a 2x2 and a 3x3 linear system. 2 variables or 3 variables. And maybe you'll like the Cramer's rule method a little bit more than elimination. I don't know, let's see. So before we start with determinants, let me ask you a question. So let's say you're programming software for a camera to allow it to allow the camera to determine whoever is in the picture, right? And there is software like this. There is an app called Recognizer, I believe, that when you hold it up to somebody's face, it goes, oh, yeah, that's Jim, or whoever it is. Okay, so my question is, what is one thing the camera needs to look at to determine your face is in an image? So the software, whatever camera is looking at you, what is one thing that it's looking at your face and going, hey, that's you? Okay, so just take a second, think about that. So for me personally, it would probably be my nose. That just my nose all by itself, that would probably be enough to determine that it's my face. Now the software, of course, would probably use more than just a nose to recognize something. But what I'm trying to make a point about here is that there's something that determines who you are. Maybe one little thing, maybe it might be a collection of things. Okay, but that's what a determinant is. We're going to be able to find a determinant of a 2x2 and a 3x3 matrix. And that determinant, it determines something, but what it exactly determines is a mystery right now. I'm going to keep it a secret. I'm going to build the mystery to pretty much the very end. Hey, maybe it won't even be in this objective. Let's see. Okay, so the image there's a 3D mapping of somebody's face, and it's just looking at points, different points on the face, and maybe putting those points together help determine who that person is. So let's start off with this exercise here. I want to find the area of this triangle using, well, it's in the coordinate plane, right? So how do you find the area of a triangle? Area of a triangle from geometry, remember the formula is 1/2 base times height. And the base doesn't necessarily mean the bottom. It could be any segment, and the height just has to be perpendicular to it. So one of the methods is, of course, use that formula, 1/2 base times height. You would just have to pick any segment as the base, and then you would find the height to it. It's got to be perpendicular. So listen to the process that's involved here. What you would have to do in order to find, let's say, the distance, let's say the length of BC, if I chose that as the base, is a distance formula between point B and point C. Okay, that's not too big of a deal. But in order to find the length of the height, here's point A. It's from one of the vertices of the triangle, and it goes to the other side, makes a right angle. But where is it? In order to find that point of intersection, you have to first find the equation of BC. Whatever its slope is, take the negative reciprocal of it and use the point A to find its equation, the height's equation, then solve that as a system of equations so you can find the point of intersection. Then, between that point of intersection and point A, you'd use the distance formula, and then you could apply the formula. Seems like a lot to do. You could do it because everything that I just said are things that we've already talked about in this class, but man, would that be a lot of work. Okay, so there is another way. Can you think of it? Instead of finding this directly, can you find it indirectly? How about this? How about we surround the whole entire triangle by a rectangle? So watch this little animation right there. We find the area of the entire rectangle and then subtract off the white triangles from it. And the white triangles are all right triangles, so they're very easy to find the area of. For example, this one from B, C to this corner point here is the base could be 1, the height could be, that's 2, 3, 4, 5, 6. So 1 times 6 is 6, divide that by 2, you get 3. So the area of just this little piece is 3. It'd be very easy to find the areas of all of those and subtract them. Okay, so the method that I'm just talking about right here in the second one, that's exactly what this thing called a determinant would do if you wanted to find the area of that triangle. It's an application of finding the determinant of a matrix. All right, now in terms of what the extra credit is for the 6 weeks, it's going to be to prove that, and I'll talk a little bit more about that shortly. So far, all we've said is that that's an application of a determinant, but we haven't said what a determinant is yet. So determinant is only for square matrices, and all it is a number that's associated with that matrix. And this is usually how I write it. Det A, DET for short for determinant, A is the matrix, or it looks like absolute value brackets that we put around A. Either one of those means the determinant of a matrix, assuming that A is a square matrix, okay? And just based on the word right there, determinant, the determinant determines something, it identifies something, but haven't said what yet. Big mystery, big mystery. I hope it's worth it. I hope the reveal is worth it. Okay, so here is then finally how you find the determinant of a 2 by 2 matrix. Very, very simple. If you can kind of cross multiply, if you can subtract numbers, you can find the determinant of a 2 by 2 matrix. So it is the difference of the products of the diagonals. Okay, so you always do the major diagonal. So major diagonal is the A times the D here, minus the minor diagonal, which is the B times the C. Okay, that's all it is. You multiply those and you subtract the two numbers, you got the determinant. Okay, so let's try this on a 2 by 2 matrix here. So I want to do the major diagonal first, so that's going to be 3 times 1 minus, and then the minor diagonal, 6 times negative 2. Now, of course, when you're doing this, you could probably do that multiplication in your head, but I did want to show the little steps there. So this is 3 minus a negative 12, so plus 12, that's 15. Since this is the determinant of that matrix A, it determines something, but what? Why don't you give a couple of these things a try? All right, so evaluate the determinant of each of these 2 by 2 matrices. All right, let's take a look at what you got and see if you got the correct answers. Okay, so whenever I find the determinant of a 2 by 2 matrix, what I'm doing is I'm multiplying the major diagonal elements and then subtracting the product of the minor diagonal elements. So it's 8 minus a negative 3, 8 plus 3, I get 11. Okay, in the middle one, I have 4, positive 4, minus 4, determinant is 0. And then finally, I got 2/3 minus 6, get a common denominator before I subtract, it's negative 28/5. Okay? All right, so how about maybe just a little harder here. Find x if the determinant, remember that looks like it says absolute value, but whenever A is a matrix, it means the determinant of A is equal to 17. Okay, so all we need to do is set ourselves up an equation here. So for this equation, let's just multiply major diagonals. So 3 times 5, we got 15, minus 1 times x, that's x. If I compute that, I get 17. So 15 minus what gives me 17? X has got to be equal to negative 2. And there I'm done. All right, so in the next video, how about we do some 3 by 3 determinants?